Start ಮಾಡಲಿ. Hello students, so welcome to the 7th semester ADC, that is Advanced Communication Laboratory. So in this laboratory we have two sections, part A and part B. So in part A we have hardware equipments kind of experiments. In part B we have MATLAB code simulations. So let us move on to the part A section. So in this I will start with the first experiment, that is TDM. It's a time division multiplexing. So aim of this experiment is to design and demonstrate the working of time division multiplexing for the pulse amplitude modulated signal. So this for this experiment equipments are required. TDM a module, that is digital multiplexing module, digital demultiplexing module. So in our laboratory we have both module in a single kit, that is TDM kit. So coming to the theoretical background of this experiment, the TDM system highly sensitive to the dispersion in common channel, so that is variation of the amplitude with the frequency or lack of proportionality of phase with the frequency. Accordingly, accurate equalization of both magnitude and phase response of channel is necessary to ensure a satisfactory operation of the system. Unlike FDM, TDM is immune to the non-linearities in the channel. As a source of crosstalk, the reason for this is the different message signals are not simultaneously applied to the channel. So main concept of TDM is time division multiplexing is a type of digital or analog multiplexing in which two or more signals or bit streams are transferred apparently simultaneously as a sub-channel in one communication channel, but are physically taking turns on another channel. The time domain is divided into several recurrent time slots of fixed length, one for each sub-channel. Okay. A sample byte or data block or of sub-channel 1 is transmitted during time slot 1, sub-channel 2 during time slot 2, so on, so etc. One TDM frame consists of one time slot per sub-channel. After the last sub-channel, the cycle starts all over the again with a new frame, starting with the second sample or byte of data block from sub-channel 1, etc. So means in a single channel many data frames has been transferred with this technique. So coming to the perform or conduction of the experiment, so kit looks in this way. So it has many blocks. We'll discuss one block each at a time. So can you observe this block? So which is what? Data generator. So in which it consists of data 1, data 2 and data 3, which is having a green color knobs. Can you observe this one? So these includes a data which are generated internally from this block, which have the slots here. So this is slot 1, slot 2 and slot 3. From that, so we can take out the bits of information. So these bits of information can be controlled by this bit pattern. So this is a data information. So in this data generator we have the ground, right? So coming to the clock generator part. So it generates internally 2 megahertz of frequency internally, as well as we have BS here, that is bit synchronization. So that is BS. One more is there, FS, that is frequency synchronization. So one more, it's a ground part, right? Coming to the input to the TDM kit part. So this is the input. So whatever the information we have here, data 1, data 2, data 3 has been connected to, so data 1 and data 2 and data 3. So you can observe here these three knobs are green in color. These three blocks are also in green in colors. This has to be connected to this data 1 to data 1, data 2 to data 2 and data 3 to data 3, right? So coming to the this below section here, again we have here internally generated clock, that is yellow color, BS and FS. These three has to be synchronized. Can you observe the yellow color knobs? So yellow color knobs to yellow color knobs you need to connect, so that synchronization between the generator as well as this TDM block has been synchronized with the help of BS as well as FS. Again we have one more ground here. So main important point is here is that ground in the data generator, ground in the clock generator, ground in the this TDM input section. all has to be grounded commonly, right? So next part is that here transmitter part and receiver part. So you can observe here transmitter and receiver. TXBS means transmitter bit synchronization, RXBS means receiver bit synchronization. One more is that transmitter FS, that is transmitter frequency synchronization. This is a receiver synchronization, right? Frequency synchronization. So you can observe here it is a time division multiplexer. Whatever the data we have given here, data 1, data 2, data 3 will come here. Then at this point TDM output will come, which consists of all three inputs, data 1, data 2, data 3 at a time, a particular time slot. This TDM output has been given to the TDM input to the TDM demultiplexer. So at the end again we have data 1, data 2, data 3, whatever the information what we sent at the transmitter side here, data 1, data 2, data 3, same information will be available at the end. This we need to cross verify using the waveforms on the CRO. Let us look into a step by step. We'll start with the inputs. See, this is the probe connected to the CRO. Just I am giving the positive part of that probe. So here data 1. So you can observe the waveforms at the CRO. You can see here the frequency of that is what, 32K around, right? In voltage of say 60 volts. So whatever it may be. So it is that similarly if I take data 2, right, you can observe the waveform here, it is 16K of some amplitude, right? Similarly data 3, so it is of say 32K, so some with some amplitude. So you can observe here data 1, this is data 2 and data 3. 3 data of information is given. Again you can cross verify here. So at the data 1 and data 2 and data 3 at the input to the multiplexer, time division multiplexer. At the end you can observe here TDM output. This is the where we need to check the TDM output, wherein data 1, data 2, data 3 all are present. You can observe in the waveform here. So in this waveform data 1, data 2, data 3 all are sent through the common channel, which consists of all three frequencies. Say data 1, data 2, data 3, three information. The same signal has been given to the TDM into the TDM demultiplexer. So this acts like a input to the demultiplexer. At the end, so we need to check the received information at the demultiplexed output. If I connect to this data 1, you can observe in the waveform. So whatever the information we sent at the transmitter side of 32K, same information is being now received, right? You can observe here it's clearly observed now, right? Now if I check the data 2 information at the receiver side, you can observe here it's again a square wave of 16K. Similarly data 3, you can observe the output, it's again square wave of 32K. So this is how we need to perform the TDM experiment. So details of theory of this one will be given again in the form of text. This is how the conduction. So it's very easy. Just I'll summarize in 1 minute how to do the connections. First you take the connection of these three green color knobs, that is data inputs to the TDM inputs, green to green. So you can vary the data pattern by using these knobs. And this is a clock generator, LO and LO to LO, 3 knobs. And then here frequency and bit synchronization of transmitter and receiver. And here we will get the TDM output. This has to be given to TDM in. So again we need to get the output at these 3. So whatever the information we have sent here from data generator, these 3 inputs, this has to appear at the end. So need to observe the waveform at data 1, data 2, data 3, these 3 graphs, TDM output, TDM demultiplexed output here. Then these are the original datas which are appeared at a receiver section, right? So we'll share the theoretical background of this experiment. So in the form of text, this is how the form of the TDM experiment. Okay, thank you.